Okay, and here's the expected value questions. So expected value, I guess, by definition here, we got to think, what is this? Okay, all expected value is what a person can expect to win each and every time they play the game. It's not a guarantee that that's what you'll get. It's sort of like your average winnings or your average losses per game. So in this case, a person can win $10. You probably won't see that they're going to win $10 in an expected value question unless the probability of winning was 100%. Then yeah, they could expect to win $10 each time they play the game. So let's take a run at this question here. And the key here is you don't actually win. We don't think about winning $10. We talk about how much you gain if you win that $10 because you actually have to pay to play. Another simple thing we have to think about is, okay, so our probability of winning in this question is equal to 2/9. Therefore, we have a probability of losing, and our probability of losing would have to be 7/9 because you win 2 here, that means you've lost 7. Those two have to add up to the 9 that it's saying that we have 9 games. Okay? So let's go do the first question, part A here. We've got our probability. I guess we can put our money gained, and our money lost here. So we actually gain if we win not $10 because we paid $2, so we gained $8. But if we lost the $2. There's lots of questions say in this case you win $10, and if you lose you win $0, but you don't actually win $0, you lose $2. And that's why this part right here in the formula is a minus. So when I go and put this stuff into the formula now, I get the probability of winning is 2/9 times the money that we gain is $8. Subtract the probability of losing is 7/9 times the money we lost is $2. So now we throw that all into our calculator. I mean, if you're comfortable with fractions, you would get 16/9 minus 14/9 in this here. So 16/9 minus 14/9. Now, you don't have to do this. You can just throw the whole thing into your calculator and hit equals, and it should give you a nice answer. So if you're comfortable with fractions, though, this is what it looks like. So it would be 2/9. And that's just fluke that it worked out to be the same as probably. But in money terms, 2/9 is the same as saying 22 cents. So now, what does this number mean? Well, this means that a person can expect to win 22 cents every time they play the game. Okay, so I know that sounds weird, but now if we extended the example and said, okay, let's say we played this game 10 times. If they played 10 times, where would they be? Well, that would mean they could expect to win 22 cents each time. Well, 10 times they play the game times 0.22 or 22 cents. They would be ahead $2.20 because of how much they would lose or win, and therefore, right? Okay, so that was question A. Question B. Let's go do question B here. Question B. All we've done is we've increased the amount of cost to play by $1. So things change here. In part B, the amount we gain is only $7 because we paid $3 to play this time. We're still winning 10, so $3 to play. we are ahead or gain $7. And the money we would lose if we lost is $3. So now, all the probabilities are still the same, so we just pump all those in. So our expected value equals 2 ninths times 7 minus, we're losing this part, 7 ninths times $3. And again, you can just throw that into your calculator. So 14 minus 1, so that's negative 7 ninths. Real quick, I believe that's 78 cents thereabouts. Let me quickly put this in. Yeah, so negative 78 cents. Now, you notice that the expected value is negative. So what does that really mean? Well, that means that every time you play this game, you can expect to lose some money. So, same situation, if we play that same 10 times, we'd multiply that by negative 0.78. You could expect to be down negative $7.80 by the time you walk out of this game if you played it 10 times. So you better have some money to bring to the table.